Alright, I want to look at our investigation. Now obviously the first thing you need to do is download Geogebra, and if you do that, I've posted this particular program on, or this program on Edmodo, so you can download that. You don't have to set it up, all you have to do is use it. So if we look at the investigation, the first part of it, just going through that, so the first part of it is to in fact look at this type of curve. We've got section 1 and we've got section 2. So what you need to try and do is talk about what M does to maximise and minimise this area. Alright, so in terms of this part, you're not really having to do any calculations, you're just playing around with the program. So all you have to do here is, if I just drag that, right, you can see how that works over here. Now in this section over here, we can see that B's set at minus 21 and a third, and the C value will change. Alright, so you can make some comparisons there. Obviously we're looking for the C value to be 21 and a third, so that will allow you to talk about our seeing how those areas go visually, and then you can actually do the algebra behind that. Alright, so that's the first one that you can do. Now the other thing you can do with this is you can print screen this for different areas. Now if you want to move this the graphics around there, see if I do that, I can get that to, I'll just click on here, move the graphic. It needs to go to that shape, and then I can actually move the whole screen so you can see a bit more of it if you like. Alright, so I think it's pretty easy to use and you shouldn't have any problems with that. Now the second program that we need to do there, if we go to open this one up here, oh, I think I've opened the wrong one. Yeah, that's the wrong one. So I'm just going to close that and open the Integral Student Investigation. That's the one that you've got, the second one there. Just while that's opening up, obviously the key thing is we're playing around with these things. Now this one here requires changing A and B, and it's simply a matter of moving A value. So you can set the A value and then you can set the B value. And again, if you want to rescale this so you can see your pictures, right, so you can rescale your graph. Now if you go to your graphic, right, you can rescale that by just clicking and dragging the axis there, and you can do the same thing here. You can move that, you can scale that so you can see your graph. Now the thing here is you can do print screen, so if you want to do that, incorporate that into there. Key thing is you probably don't have to do too many print screens. What you need to then do is just use this table to complete this table in here. Now what I would do is I'd cut and paste that into your Word document. Keeping in mind we want to actually know the value of A for when the area is actually equal to 0. Alright, so in other words the area above and below the axis are going to be equal, aren't they? So that's the first part, and you've got to do some algebra there to try and prove that as well. So using your table above, make a conjecture up. So you need to state a value of A and B for those things to be equal, and see if there's a pattern in the table. And then you've got to use some algebraic techniques to try and prove that conjecture, which is really important. Now part B of the investigation requires looking at trying to prove that there is a way of working out the volume of a shape which is circular, so it's not uniform all the way through, using a technique. So the first bit, you're starting with something which you should know. You should recognise that being as a semicircle with a radius of 3, and then going to the general case over here, and then trying to show that the volume of that particular case will be given by a certain formula, using the formula for a sphere which is 4/3 pi r cubed. And considering we've got a hemisphere, so it'll only be a half of that. And then we can actually show that this particular formula will model obviously any case where you've got a curved shape, which, you know, obviously has a spherical nature at the end. Right, so that's what we're trying to prove here. So it's really about proving that this formula works so we can use it in the second part of the investigation. Alright, part C. Alright, so part C requires you to come up with your own model. So go get a camera, take a picture. Alright, and I'll just go through this example. So I just did a picture of a wine glass. I measured that distance there as being 11 centimetres. I then put a grid into my particular shape. Alright, so that's a scale diagram. Then I could go to each of these points here and estimate what they would be in terms of their coordinates. I'll put that into a Excel spreadsheet. I could then highlight that data and then I could actually come up and model that. Alright, so using a range of models, I've only shown 3 here, but you could also do an exponential model or a power model, or it doesn't really matter what it is. You can have a go at doing that, keeping in mind that obviously you can compare the R-squared values. So you could do a whole range of them and then put them into a table to compare what you think is the best of those models. Now, it won't necessarily always be the R-squared value, that's the key thing. The case here, when we're looking at our model, we don't really have to worry about extrapolating out because we're only looking at a definite integral range. So keep that in mind. You want to be talking about that when you start, analysing your results. So, I mean, that's the discussion bit. All right, if we're going to go through the checklist there, so obviously once you've got your integral there, then you can actually use that formula to go through and find the area, find the volume. And once you've got that, it's really pretty simple to go through that concept. All right, so I've done a bit of a checklist here for me from when I mark it. That will actually help you make sure that you're ticking things off when you're going through the investigation. So you need to find the value that minimises the area and the maximises. You need to do that algebraically. You need to complete the table for A and B values and then come up with your conjecture and prove that. And summarise your findings, obviously for part A. Part B is really about the proofy stuff, going through those steps there. And then part C, you need to model your information there using a range of functions, using integration to find the volume of the object, and then we're comparing the different models, and obviously we're discussing the sort of errors and accuracy that we might have to minimise. Alright, so it's obviously open-ended enough for you to explore some other ideas. So be creative with it, have a bit of fun with it, and hopefully you'll learn something from that will help you with your topic. Alright, so obviously talk to me in class if you need some help. Get a draft done really early. You can show me what you've done so I can check that you're on the right track. Good luck with it.